One of the great things about linear equations is that you can actually check your answer when you're finished. So we're going to start off by doing that. We call this checking our answer by substitution. So let's have a look at the example. In this example, x plus 3 over 2 equals 4. So we can say that the left-hand side is equal to x plus 3 over 2. By substituting for x equals 5, we can then replace the x with 5. So that becomes 5 plus 3 over 2, which is equal to 8 over 2, which is equal to 4. This is the same as the right-hand side. So we have shown that this is actually a true solution, one that works. In the second example, I'm going to need to work out what both sides of the equation are because there is no simple answer on either side. So let's do left-hand side first. The left-hand side is 3a plus 5. That's equal to 3 by 2, because a is 2, plus 5, which is 6 plus 5, which is 11. The right-hand side is equal to 6a minus 1, which is equal to 6 by 2 minus 1, which is also 11. So then I can write left-hand side equals right-hand side, and I've shown or proven that a equals 2 is a solution. Now we're going to solve some one-step equations. In each of these equations there is a number with a letter that stops it being by itself. What we really want is an answer like this one, x equals some number, which will be the answer. So the procedure is, first of all, we need to find out what's stopping x being by itself. In this first question, it's the minus 5. This minus 5 stops x being by itself. So what we need to do is get rid of it. Now, the only legitimate way to get rid of something is to do something to both sides of the equation. So I'm going to write the equation out, leave a bit of a gap, and think, what is the opposite of subtracting 5? The opposite is adding 5. So I'm going to add 5 to both sides of the equation. By doing that, I get what I really want, which is minus 5 plus 5 makes 0. That means x is now by itself on the left-hand side of the equation. And 10 plus 5 is 15. So x equals 15 is the answer. I have made x the subject of the equation. I have solved for x. If I check my answer, 15 minus 5 does actually equal 10. In the next question, a plus 5 equals 15. I want to have a equals. What is stopping it being by itself? The plus 5 is in the way. So what we need to do is get rid of the plus 5. So let's write it out again. To get rid of plus 5, the opposite is subtract 5. So I do the same to both sides of the equation. When I do that, I can look and see that plus 5 minus 5 is nothing. So a is equal to 15 minus 5, which is 10. Let's check that. 10 plus 5 does in fact equal 15. In the third equation, we've got 3p equals 18. The symbol between the p and the 3 is multiply. The opposite of multiply is divide. So I'm going to divide both sides by 3. That means this 3 and that 3 cancel to 1. 1 times anything stays the same. So in fact, the left-hand side now is just p. On the right-hand side, I've got 18 divided by 3, which is 6. Let's check our answer. 3 times 6 does in fact equal 18. So this is my solution to the equation 3p equals 18. Let's look at the last one. Between the g and the 4 is a divide. So the opposite of divide is multiply. So I'm going to multiply both sides by 4. You notice that it doesn't matter whether I put the 4 first or second, because with multiply, 3 4s is the same as 4 3s. When I do that, I can cancel the 4s and get 1. So that means that I just end up with g on the left-hand side of the equation, and 8 is the answer. And let's check it. G divided by 4, or 8 divided by 4, does in fact equal 2. In the last section, we were doing questions where there was only one thing to get rid of. If you've got more than one number to get rid of, you need to be careful what order you do it in. In maths, you would have learnt that using BODMAS or BIMDAS will help you remember what order of operations you need to do when you're solving problems. And that you would have learnt that you do brackets first, indices next, multiply and divide after that, and then last, addition and subtraction. With linear equations, when we're getting rid of things, because we're taking them away, we do BIMDAS or BODMAS in reverse order. We get rid of addition and subtraction first, multiplication and division next, indices next, although we won't have any indices in these equations we're doing in these lessons, and then brackets last. Let's look at an example. We've got 2c plus 5 equals 11. There are two numbers to get rid of, the 2 and the 5. Using BODMAS backwards, you can see that you need to get rid of the plus 5 first. So let's write that out and get rid of the 5. 2c plus 5 equals 11. The opposite of adding 5 is to subtract 5, so I do that to both sides of the equation. When I do that, plus 5 minus 5 makes 0. So now I have 2c equals 6. This is a new equation, but it gives the same answer as the top one. There's still one number to get rid of, and that's the 2. Between the 2 and the c is a multiply, so the opposite of that is to divide. So I'm going to divide both sides by 2. The 2's cancel on this side, and I end up with c equals 6 divided by 2, which is 3. So the answer to that is 3. Let's check it. Up here, 2 times 3 is 6, plus 5 is 11. Great, I know I'm right. In the next question, it looks like there's only one number there, but that minus, with the d, we can think of it as being minus 1d. And you can see that that's something else to get rid of, the minus sign. So let's write that out. Again, the 7 is actually the thing we need to get rid of first, because between the 1 and the d is really a multiplication sign. So 7 minus d equals 2 minus 7. When I do that, the 7 and the minus 7 make nothing. So what's left is minus d equals 2 minus 5, which is minus 5. Now I need to get rid of that minus 1 in front of the d. Think of it as being a minus 1. So I'm going to divide both sides by minus 1. If I do that, then minus 1 and minus 1 cancel, or another way of thinking of that is 2 minuses make a plus, and I just end up with d. On the right-hand side, minus 5 divided by minus 1 is plus 5. So let's check our answer. Up here, 7 minus 5 equals 2. Now let's look at the next question. Y over 6 minus 5 equals 1. There are two things to get rid of, the 5 and the 6. We get rid of the minus 5 first because it's a subtraction. Y over 6 minus 5 equals 1, so I'm going to add 5 to both sides. When I do that, these two make 0, which is why we did it, and we left with y over 6 equals 6. Now I need to get rid of the 6, so to do that I'm going to multiply both sides by 6. These two cancel, so I end up with y equals 36. Let's check that. 36 divided by 6 is 6, minus 5 equals 1. In the last question, we've got two numbers. One's multiplied by the x, that's the 4, and one's divided, that's the 5. It doesn't actually matter which one you get rid of first here because multiply and divide are the same order of operation. So I'm going to get rid of the divide first. So let's write it out. 4x over 5 equals 40. Multiply both sides by 5 so that they cancel on this side. So what I'm left with is 4x equals 200. Let's divide both sides by 4, which is the opposite of multiplying. Cancel those two. So x is equal to 200 divided by 4, which is 50. If I check that, 4 times 50 divided by 5 equals 40.